Hello guys, Doctorbass here. So I was moving some of the battery that I have in my lab and I decided to make a quick video to give you some information about the Zero Motorcycles battery. So as you can see here on the back, this is my Zero. This is a 2017 Zero SR with the ZF13 battery inside, and I have also what is called the power tank inside. So this is an additional module that is connected in parallel with this one. This is optional. So to give you a little idea on how these high kilowatt hour, very power dense battery are made, here is a ZF 12.5. So this was 2 years before the years of my Zero. So this is a 2015 battery. It is made of 4 modules. That is called, these are called the bricks. So you see here, there's one brick, another brick, a second one, and a fourth one. So these are made of pouches made by Ferezis, as you can see here. And these are 25 amp hour cells. Okay, so these are using pouches that are stacked in this direction. Okay, so you have 28 cells stacked all in series here, and this is 28S 1P per brick. And this allowed them to make multiple size of battery. They just had more in parallel to have a higher kilowatt battery offering on the Zero model. So on the Zero FX and the FXS and FXE, I think there's some brick like that, and you can have 1 or 2 on the Zero that are removable. They have their own BMS. On this battery, which is normally you see there's aluminum here, so it is all protected by aluminum, but I just removed that. Normally there's a BMS circuit board that is here. I think I have here. Wait a minute. Yeah, so we have the BMS here. So this is a 28S BMS. This is a very advanced BMS. To tell you some information about that, this BMS is actually storing the number of time each single cells from the 28S group has been bleeding, so balancing, if I can tell. So if you have one single cell that never bleed, it means that it's probably a faulty cell or something like that, because all the other group have to bleed to equalize to the same cell that is probably self-discharging too quickly. So this is a really advanced BMS that is communicating with the Zero as well. So here, this is the second gen battery, I will say. Not in terms of size, but in terms of structure, if I can tell. The first battery from Zero were made from 26700 cells from moly cells. These were 2.9 amp hour cells, and it was a 3 kilowatt hour pack. Now, with these battery, they began with the 11.4 kilowatt hours, which had 10 kilowatt hour usable. So each brick wire 2.5 kilowatt hour. So on this one, it is normally 27 amp hour cells, but they indicated 25. I don't know exactly why. Probably the usable capacity. Normally you will have 2.7 kilowatt hour per module here, per brick, if I can tell. And then from 2016 to 2017, they moved to what it's called the long brick. So these are the short brick, and these are the long brick. So these, in fact, are about the same kind of cells, same cell format, except that these are made of 2P28S. So instead of having 1 brick, 2, 3, 4, it's just 2 long brick of twice the kilowatt hour per brick. So this reduced the number of connections, the number of aluminum, and it's increasing a little bit the power density. So as you can see, these are connected quite differently. You have big pulse here, so this is about 110 volt DC here. On these modules, these are the bus bars that are made of copper, nickel plated copper, and there's a ceramic coating on top of these. So these are not conductive here. And so only the electrified part are exposed like that, but they even put epoxy onto these to protect. And there's a ton of this kind of dielectric grease all around. It's quite messy when you disassemble that. You will find all that kind of grease all around. It will find its way on you for sure. So you see all the connections between the bus bar connections between the parallel batteries. And these batteries were about, it's about 52 kilowatt maximum from the motor controller, which is a Sevcon size 6 controller, the same model as I have on mine. So it's draining about at 102 volt about 500 amp, 550 amp for these total 4 brakes. Now on these two, it's this one is a ZF 14.4, so in fact this is 7.2 kilowatt hour and 7.2 kilowatt hour. So to just give you an example, here's my hand here compared to this one, and you see the size. So this is exactly the same size as this one, except the format is quite different and the orientation is different and the connections are different. There's bus bar to connect these, which look like something like that. Quite good quality connectors you can see here. Yeah, so even the big fuse here. So this is what I call the fuse. 350 amp continuous and very large bus bars. And then the last gen from zero is exactly these, which is called the BCB, bilateral battery. So instead of having these kind of pouches that are the same size as this here, they moved to a new format size of cells, still made by Fluoresys. These are the P73 cells. So the cells are like this dimension here, and there's a 2 stack. So this module here is in fact a 7.46 kilowatt hour. This is fantastic. There's no handle on these. This is just me for fun to transport these that I added these. So these are about 70 pounds for 7.5 kilowatt hours. The big difference on these is that in fact these are in series. So this is a 14S module in series with another 14S module. And the BMS are likely, there's one master and one slave. They are connecting here. These are small BMS, and they connect here just to measure the voltages, and then through something like a CAN bus or a link bus, they transmit these data. And all the bleeding resistors are here, but these are very small. And the way they are made is very fantastic, because it's very rare that you will have water intrusion inside these modules. Why? Because they are fully potted. So you see there's an inlet here, and somewhere else there's an outlet probably. So they inject the kind of potting inside to fill all the air gaps, air spaces by some potting inside. And this is a very, very studied potting for this kind of purpose. So the battery structure is quite simple. It's a sheet metal box between, and all the cells are in sandwich between 2 thick plates of about a 1/4 inch, maybe a little more, 5/16 of an inch thick here and here, and there's 28 cells here. On this one, this is exactly the same thing. You have this big plate, except this one has been machined. And you have 56 cells this way, 56 cells this way. And on these, this is the 32 amp hour cells. So you see from the various generations, for the same exact size, the first zero brake in 2013 were 25 amp hour cells, okay? And now they are up to 32. So that's a very big evolution, and even the C rate has been increased. So normally these cells are something like 5C continuous, 7C boost or burst or something like that. Now on these bilateral battery, you see this one There was insulation problem on one of the Zero that I got the battery from, and I saved these modules. So I've measured 7.49 kilowatt hours on this one, and the nominal is 51.4 volt. So these are quite performant, because actually this is I think it's a 2022 battery, and it's still 3 years old, and I measured exactly the same capacity. So that is quite fantastic. And you see the polarity is, so you have the negative here, positive here. So this is a stack of 56 cells, parallel series 28S 2P, and then it's connected in series here. There's a bus bar here, and then it's connected here through the motor controller. The motor controller that is with this battery is supplying a motor for 82 kilowatt at the wheel. So that is quite powerful. So 82 kilowatt under 102 volt, which is still the same voltage that they use since 2013. So 102 volt, 82 kilowatt at the wheel, probably 90 kilowatt into the motor controller or something like that. That is about 900 amp of current. And what is fantastic on these is that you will see they use 2 terminals to connect that huge current. And the servicing on these, what is quite interesting, is that these kind of bolt are insulated. This is a very hard plastic that is surrounding the bolt. So even with their tool, the guy that will service these will not risk some shorts or something like that. So you see the exposed terminal here. And what I like is that all the kind of bus bars here are also protected with plastic, so only the exposed part is conductive. So very low risk of short or something like that. Even you see that is the bus bar that will connect these two in parallel, and you see there's a fuse in the middle. And even the current sensor is also in the middle, and this is all surrounded by kind of a liquid rubber that is dried or something like that, and only the exposed part. So when they connect these, they will put the bolt onto this one, and normally there's a seal here. So everything is perfectly sealed. So that is quite a great evolution from Zero motorcycles. So guys, I wanted to share that with you because this is kind of a great advanced battery. You know, motorcycles cannot have very heavy and huge battery like ESS on your power wall or something like that. So you need very power dense battery. So that is quite a good evolution. The first Zero battery had 10 kilowatt hour in the same shape of that in 2013. The first of that generation, I mean. Then they moved to this one with about 12.6 kilowatt hour usable, and then to this one, which they call the ZF 17.3, which is in fact what they call it, close to 15 kilowatt hour usable. So in this you have 15 kilowatt hour. That is quite power dense, and even, you know, there's some room here because they put some hair blower here to cool down these cells. So if you will bang on these, it's like a brick, you know. If I will hit concrete like that, it's exactly the same sound. You see, maybe I need some harder parts to convince you, so I will use that. You see, no air inside. This is very, very dense, but I can still lift it, you know, but I will not get it to my foot. So I hope you appreciate it, guys. That is something that I wanted to share. So I have 3 different generations of Zero battery here. This is the last gen, and this is same form factor as the 2013. So this is still 12 years of Zero battery evolution that you have in front of you now. I hope you appreciate it. Thank you, guys, and have a nice evening. Bye bye.